Introduction. Dynamic programming is a powerful technique used in computer algorithms that can help solve complex problems efficiently. It involves breaking down a problem into smaller subproblems and solving them one by one, using the solutions to build up to the final solution. This approach can save time and resources compared to other methods. In this video, we will explore the world of dynamic programming and its importance in computer algorithms. By the end of this video, you will have a better understanding of how dynamic programming works and why it's an essential tool for any programmer. So first we're going to talk about research and analysis. So research and analysis is creating an effective presentation on dynamic programming requires thorough research and analysis. This process involves gathering information from various sources, including academic papers, textbooks, and online resources. It's essential to ensure that the information is accurate and up-to-date, as well as relevant to the topic at hand. By conducting thorough research and analysis, you can gain a deeper understanding of the subject matter and identify key concepts that need to be covered in this video. This will help you create a more engaging and informative presentation that resonates with your audience. Script and storyboard. It's important to develop a clear script and storyboard. The script should outline the key points that need to be covered and the order in which they will be presented. The storyboard should provide a visual representation of the presentation, including any diagrams or animations that will be used. Having a clear plan in place can help you stay focused and ensure that you cover all the necessary information. It also allows you to see how the presentation will flow and make any necessary adjustments before starting to create the final product. Diagrams are an essential tool for explaining complex concepts in dynamic programming. They provide a visual representation of the problem and its solution, making it easier for the audience to understand. Diagrams can take many forms, including flowcharts, graphs, and tables. In this video, we will use diagrams to help explain some of the key concepts in dynamic programming, such as overlapping subproblems and optimal substructure. By using clear and concise diagrams, we hope to make the video more engaging and informative. Dynamic programming diagrams are powerful visual tools used in computer algorithms to illustrate the step-by-step optimization process. These diagrams condense complex problems into simplified representations, allowing for a clearer understanding of the underlying structure and optimal solutions. By breaking down a problem into smaller subproblems and using a recursive approach, dynamic programming diagrams showcase the overlapping substructures and help identify the most efficient path to the final solution. The arrows and nodes in these diagrams depict the relationships and dependencies between subproblems, guiding the algorithm towards finding the optimal solution. Animations are another powerful tool for explaining dynamic programming concepts. They can help illustrate how the algorithm works step by step, making it easier for the audience to follow along. Animations can take many forms, including videos, GIFs, and interactive simulations. In this presentation, we will use animations to help explain some of the more complex dynamic programming concepts, such as memoization and tabulation. By using engaging and informative animations, we hope to make the presentation more memorable and impactful. Memoization and tabulation are two common techniques used in dynamic programming to optimize algorithm performance. These techniques can be effectively explained through animation. In the animation, we can depict a recursive dynamic programming algorithm that solves a problem by breaking it down into smaller subproblems. As the algorithm progresses, we can show the memoization technique in action. A memoization table or cache can be visualized, where computed subproblem solutions are stored for future reference. As the algorithm encounters a subproblem, it first checks the memoization table to see if the solution has already been computed. If so, the algorithm retrieves the solution from the table, saving computation time. If not, the algorithm proceeds to solve the subproblem and stores the solution in the memoization table for future use. Next, we can illustrate the tabulation technique through animation. The animation can display a table or array that represents the subproblems and their solutions. The algorithm starts populating the table from the smallest subproblems and gradually fills it up with the solutions in a bottom-up manner. Each entry in the table corresponds to a subproblem, and the algorithm fills in the solutions by iteratively combining the solutions of smaller subproblems until the final solution is obtained. Throughout the animation, we can highlight how memoization and tabulation help avoid redundant computations and significantly improve the efficiency of the dynamic programming algorithm. By visually demonstrating the process of storing and retrieving solutions from the memoization table and the systematic filling of the tabulation table, viewers can gain a better understanding of how these techniques optimize the algorithm's performance. Overall, an animation showcasing the concepts of memoization and tabulation in dynamic programming can effectively illustrate their benefits and help learners grasp these techniques in an engaging and intuitive way. In conclusion, dynamic programming is a powerful technique used in computer algorithms that can help solve complex problems efficiently. It involves breaking down a problem into smaller subproblems and solving them one by one, using the solutions to build up to the final solution. By understanding dynamic programming, programmers can develop more efficient and effective algorithms. We hope this video has provided you with a better understanding of dynamic programming and its importance in computer algorithms. We encourage you to continue learning about this fascinating topic and explore its many applications in the world of computer science.